So the focus of this video is going to be spark plugs and spark plug wire service. We're going to be going through the process of removing spark plugs, checking and inspecting spark plugs, as well as our spark plug wires. Now the steps that we're going to follow can be used on any vehicle that you're working on. We will touch on some of the differences from one vehicle to another as we go as well. Now before we can get started removing spark plug wires from the vehicle that we are going to be working on, which is our Pontiac Montana van, we need to locate what the numbers of the cylinders are. Remember, cylinder numbering is important so we can identify what cylinders fire in what order. So we're going to go ahead and look at all data and determine the cylinder arrangement of this vehicle, and we're going to label spark plug wires for the cylinders where we will be removing the spark plugs first. So we'll go into all data and we will select our 1999 Pontiac van. And what we are looking for is the cylinder numbering. So there's a couple different ways that we can get there. What we're going to do in this case is we're going to go under engine, cooling, and exhaust because we are dealing with the engine. And then more specifically go to the engine. And then what we want to try to locate is our cylinder numbering. And I think the best place to find that is under our firing order. And notice that our firing order on this engine is 1, 2, 3, 4, 5, 6. That is not a common firing order that you will see. However, in this case, the cylinders do fire in that order. Now remember, the cylinder numbering is different than the firing order. This is the order that the cylinders experience their power stroke in. The cylinder numbering is where these cylinders are located relative to the engine block. So we're going to go to this C number 1 cylinder link, and you'll see that we get a diagram of the cylinders of the engine, starting with the front of the vehicle. So in the front of the vehicle, which is what we're going to focus on today, we have cylinders 2, 4, and 6. Cylinder number 1 is on the back side of the engine. Again, for our purposes for today, we're going to focus on just the easy cylinders to get to, which are 2, 4, and 6. And those will be the ones specifically we'll be removing the spark plug from cylinder number 2. So before we can get started, we want to go ahead and we want to label our spark plug wires for the correct cylinders. So this is our cylinder number 2 spark plug wire. We're going to go ahead and put a piece of tape around that and label that as our number 2 cylinder. So we'll label that number 2, and then we can repeat that process for the remaining cylinders. So you can see we have our cylinders now labeled: cylinder 2, cylinder 4, and cylinder 6. Now, before we can begin removing our spark plug wires and our spark plugs from our engine, we want to make sure that we protect our eyes. So we want to wear our eye protection for this process. We're going to go ahead and remove the spark plug wire and the spark plug from the number 2 cylinder. But again, we can repeat this process throughout the engine. You're going to focus on 2, 4, and 6, which are the front 3 cylinders of the engine. But remember, there is a bank in the rear of the engine that we would have to remove spark plugs from under certain circumstances. But from a learning standpoint, I'm showing this to you on the cylinders that are the easiest to get to. So we'll go ahead and remove our spark plug wire for our number 2 cylinder. And we'll set that off to the side. Again, we could repeat this process for other cylinders, but we do want to make sure we do label each of them before we remove them, so we end up with them back in the correct locations. We're now going to use a socket and a ratchet to remove our spark plug from our engine. Again, we want to be careful not to damage the porcelain of the spark plug. and we can carefully remove the spark plug from the engine. We'll take this over to the bench and we'll take a little closer look. Now, as we take a closer look at the spark plug, there's a couple things that I want you to note. One of the things that I want to pay attention to is the end of the spark plug is in fairly good condition. When we look at the gap, for example, we notice that the spark plug, the side electrode, is not really eroded away. We do have some carbon buildup on the spark plug, but it's not really heavy. The spark plug is a little bit wet with fuel. That could also be from the engine sitting as it has, so that's something to be aware of but not be super concerned about. One of the things that we want to do is we want to actually measure the end gap of this spark plug, and we're going to do that using feeler gauges. You'll notice about feeler gauges is they are made up of these little metal leaves, and these leaves are each machined to have a very specific thickness to them. And if we look on the actual feeler gauge, we can see that they are labeled with their thickness. The thickest leaf in this feeler gauge is 40 thousandths of an inch thick. So what we can do is place that inside of our end gap of our spark plug, and we're looking for the leaf that fits in the end gap of our spark plug without necessarily fitting tight. We want just a slightly snug fit. And this one obviously fits very loose. So what we're going to do is we are going to start working our way down. We're going to double up and start working our way up to where we get sort of a snug fit. So I'm going to go ahead and I'm going to take a 15. I'm going to double up a 15 with my 40. And let's see what we come up with. So with a 15 and a 40, we do have to be careful with this because it is easy for two of these to get stuck together. So there's my 15 and my 40. And the 15 and the 40 together still fits a little bit loose. So that puts me at about 55. So I'm going to go ahead and I'm going to add another few thousandths of an inch to this. So I'll double up. I'm going to go a 40 and a 20 and see what that gives me. Alright, so with a 40 and a 20 together, that's about 60 thousandths. And that gives me a nice snug fit in my spark plug. So my end gap on this spark plug is about 60 thousandths of an inch. So what does that mean? Is that within specification? Well, what I have to do is I need to now check that on all data. So we're going to go ahead and look at the specification for our spark plug end gap. So we're back under engine, and we're going to search for spark plugs. Spark plug. And under spark plug, let's look up specifications. And we're not really interested in the torque right now, we're interested in the gap. And what they call for is 1.52 millimeters or 60 thousandths of an inch. So this particular spark plug is within specification for end gap. That would be an indication that the spark plug has not started to burn away, and that's a good sign for the use of the spark plug. Now, I would still recommend, if this vehicle is at a point where the service schedule is recommending the replacement of the spark plug, I would still recommend that replacement. If this vehicle is not at a point where we're recommending replacement of the spark plug, then it would be okay to continue to use the spark plug, because there's really nothing that has demonstrated to be an issue. Now keep in mind, if I was seeing a problem like a spark plug that was eroding away, or I was seeing a spark plug that was covered in carbon, that's not necessarily a spark plug related problem, or even an ignition related problem. There could be some other problem, but I can use my spark plug as a diagnostic tool for determining this. So we're going to go ahead and we're going to reinstall our spark plug on the vehicle. And so we'll reinstall our spark plug, making sure to start the threads by hand. This is a little bit of a tight spot to get to on this vehicle. It does take a little bit of maneuvering to get that spark plug to start. But we do want to try to start the threads by hand, holding on to the tip of the spark plug. If we have difficulty getting it to start by hand, we can use our extension for the process. But if doing that, we want to make sure that we're not using that with a wrench at this point. A wrench gives us too much leverage and increases the possibility that we're going to cross-thread our spark plug. If we're spinning just the socket with our hand, the likelihood of cross-threading the spark plug is very low. And once the spark plug is in hand tight, then we can go ahead and use our ratchet. Now, my general rule for tightening spark plugs is we want to seat the spark plug, meaning we want to turn it all the way down. Now, this is a used spark plug, so I should point out that this spark plug will not turn as far after it makes contact as a new spark plug. A new spark plug has a washer on it that needs to be compressed. Typically, with a new spark plug, you will get about a half a turn out of that spark plug once you put the wrench on the end of the socket. In this case, we're most likely only going to get about an eighth of a turn, and that's fine. We don't want to over-tighten spark plugs because we can very easily damage the spark plug or the cylinder head. So again, about an eighth of a turn, that spark plug is tight. And I'm going to go ahead and reinstall my spark plug wire, making sure that the spark plug wire snaps into place. And you will hear a click if that spark plug wire is properly in place. After that, I can remove my labels because we are done with them. And again, this process could be repeated for the other spark plug wires on the engine as well. Okay, now that we've talked about spark plugs, we're going to talk about spark plug wires. So we're going to use a different vehicle as our subject for spark plug wires. We're going to go ahead and use our 97 Pontiac Bonneville, just because it's a little bit easier to see what I'm doing here with the spark plug wires in this case. And we're going to start by removing the number one spark plug wire. Now you'll note on this engine, somebody has done a really nice job of labeling these. If they hadn't done this, we would want to go ahead and do this just like we did on the van. Our ignition coils in this case are already labeled and much more accessible than they were on the van. On the van, they were at the back of the vehicle. This particular vehicle has 3 coils. It's a 6-cylinder engine, and it uses 1 coil for every 2 spark plugs. It's actually what's called a waste fire ignition, meaning that it fires twice during the engine cycle. We'll deal more with that down the road, but the bottom line is we need to remove the number one spark plug wire at both ends. So we're going to remove it from the ignition coil. Notice it's labeled at the ignition coil end, and the ignition coil is labeled as well. So we don't have to worry at all about mixing the spark plug wire up. So we're going to go ahead and unplug it from our ignition coil and unplug it from our spark plug. Now there is a clip that keeps this in place. So we'll go ahead and use a screwdriver to remove that. And we can remove our number one spark plug wire from our engine. We'll bring this over to the bench and we'll do a little analyzing. Now, just something that I want to note about spark plug wires, not every vehicle today has them. What some manufacturers have done is gone to what's called a coil on plug design. With a coil on plug design, there is no need for a spark plug wire. This is actually your ignition coil, and it attaches directly to your spark plug wire. So we'll talk more about that when we talk about ignition coils down the road, but this is just something that I wanted to point out. But if you are still working on a vehicle that has spark plug wires, they are a maintenance item and we do want to pay attention to them, just like we would with any other maintenance item on the vehicle. Now there's 2 things that we need to measure about this spark plug wire. We need to measure the resistance of the spark plug wire, and we need to measure the length of the spark plug wire. The reason the length is important is the specification for resistance is going to be based on the length of this wire. So what I'm going to do is I'm going to go ahead right now and I'm going to go into all data and I'm going to look up for this vehicle what the proper specification for spark plug wire resistance is. Now, I just want to note that some manufacturers call parts by different names, and that's something we should be aware of. In this particular case, spark plug wires are also referred to as ignition cables, so it's something that we want to make sure that we're aware of. I'm going to change my vehicle, and I'm going to go ahead over to the 97 Bonneville. I happen to already have this vehicle stored in memory. And I think we'll go under engine again. And under engine. And we're going to go ahead and we're going to select ignition cable, because that's what they call this on this particular engine. Again, ignition cable, spark plug wire, two different names used for basically the same part. And we'll look up the electrical specification. Now, we're given some different information about how to measure the spark plug wire, but what I'm really concerned about is this measurement. It says that each spark plug wire should have a resistance of approximately 5,000 to 10,000 ohms per foot of length. And that if the resistance reads over 30,000 ohms, no matter how long the plug wire is, or fluctuates from infinity to any value. Now, fluctuating from infinity, an infinite value of resistance would mean that there is unlimited resistance. And what that basically means is this plug wire is what we call open. It means that there is no or next to no electrical connection through the spark plug wire. That would be an indication that the wire has almost a complete break in it or a complete break in it, and that that wire should no longer be used. What we want to do is we want to go ahead and take a length and a resistance measurement of our spark plug wire. So the first thing I'm going to do is I'm going to get a measurement of the length of my spark plug wire. Now, I don't have to be super accurate with this. I'm going to go ahead and round to the nearest foot. If you remember, I'm allowed a pretty big range of values, 5,000 to 10,000 ohms, which is, by the way, also known as 5 kilo ohms to 10 kilo ohms. Okay, there's 1,000 kilo ohms in 1,000 ohms in a kilo ohm. So we'll go ahead and we'll measure the spark plug wire, and we're coming up with a total distance or total length of about 12 inches, which would be 1 foot. So that tells us this spark plug wire is approximately 1 foot long. We're now ready to measure the electrical resistance of our spark plug wire, and we're going to do that using a tool called a digital multimeter. Now, we're going to use these quite a bit. This is going to be one of our first times using this, and we're going to be measuring resistance. The way this tool works, if you remember, there's really 3 measurements of electricity that we focus on. There's voltage, resistance, and current. What this multimeter does on the resistance setting is it sends out a small amount of electrical current. And using the measurement of that small amount of electrical current, it determines the amount of resistance of the conductor, in this case the spark plug wire, that we are measuring. What we're going to do is we're going to set our meter to the 20 kilo ohm scale. Why 20 kilo ohms? Well, that's the maximum that we would be able to measure. That's 20,000 ohms. We already know that specification for this spark plug wire is 5,000 to 10,000 ohms based on the length. It was 1 foot long, and we're allowed 5,000 to 10,000 ohms per length. So that would be our range of values that we're allowed, 5,000 to 10,000 ohms. If this spark plug wire was 2 feet long, we'd be allowed 10,000 to 20,000 ohms. We're going to set this meter now to the 20 kilo ohm scale. So I'll go ahead and I will adjust this to 20 kilo ohms. And we'll notice that what it displays is a 1. What that 1 means, that's an infinite resistance reading. I want to show you what happens if I go ahead and touch my leads together. Notice that it drops pretty close to 0. Okay? And actually eventually does drop down to 0. That means there is next to no resistance. Well, there's next to no resistance because I'm touching my 2 leads directly to one another. The next thing that we want to do is we want to touch our leads to each end of the spark plug wire. Now, it is important when we do this that we make sure that we are actually touching the metal inside the spark plug wire. And we'll do this with both ends of our multimeter. And you can see we are getting a reading of approximately 1.42 kilo ohms. That is 1,420 ohms. Now, I want to note something about that. What was our minimum resistance value? It was 5,000 ohms based on a 1-foot wire. We are significantly lower than that minimum resistance value. We already know that if we had a higher resistance value, it would indicate that the spark plug wire was likely no good, although looking at the spark plug wire, it appears to be in pretty good condition. What I think likely happened here is that this spark plug wire was probably replaced. Remember how well it was labeled before we removed it? I believe that the spark plug wire was likely replaced with a low resistance wire. Now, why would somebody do that? Well, here's what we need to know about resistance in spark plug wires. A higher resistance spark plug wire will generate a hotter spark. This has to do with the way the coil generates the potential needed for the spark to jump the gap on the spark plug. A higher resistance will give the coil the ability to build up a higher voltage prior to the spark jumping the gap. The downside to that is it also makes that ignition coil work much harder. Having a higher resistance spark plug wire is harder on the ignition coil. In this case, we have a low resistance spark plug wire, which is easier on our ignition coil, which is a good thing, but we're not going to get quite as hot of a spark. So what do we do in this case? My recommendation would be to use the recommended spark plug wires for the vehicle we are working on. However, it's unlikely that with these spark plug wires we're ever going to see a real problem from this vehicle. It's just something that's important to note. And again, this is something that it's not the original part. It was likely replaced, and it was replaced with a lower resistance spark plug wire. For our purposes, we're going to leave these on the vehicle. Again, this is not something we would do if the resistance value was too high or if it was close to an infinite value. But in this case, we are totally fine. Now, if we're doubting our measurement, what we could do, because we found that this measurement is lower than even 2,000 ohms, we're going to go ahead and we're going to set this down to the 2,000 ohm scale, and let's retake this measurement just to get a little bit more accurate reading and really confirm that we are not experiencing an issue with the instrumentation here. And you can see when we read our value, we do get a more accurate reading. I'm getting a reading now of 1,419 ohms. Still significantly lower than that minimum specification, but again, if it was higher, I'd have concerns. It's not higher, it's lower. We're going to go ahead and reinstall the spark plug wire on the vehicle. So we'll go ahead and reinstall our number one spark plug wire onto our coil first, making sure it clicks, making sure this is the number one spark plug wire. It's going to the number one label on the coil, and it's going to our number one cylinder on the engine. Just something to point out, notice the cylinder numbering on this engine is different than the one that was in the van. Our number one cylinder is our frontmost cylinder, and the cylinders are numbered 1, 3, and 5, and on the back side of our engine we have cylinders 2, 4, and 6. We'll go ahead and reinstall the other end of our spark plug wire onto our spark plug, again making sure we get a solid click. And we can also reinstall the spark plug wire into our clip. I'm going to go ahead and loop this so that the spark plug wires run parallel with each other. We actually want to avoid having spark plug wires cross over one another. We get less interference, or less potential interference between those spark plug wires if they're not crossing over one another too much. That's why we keep them separated with a clip. Okay, so this has been spark plug and spark plug wire service. Components that are wear items on a vehicle, they do last much longer than they ever did before. That's something that I want to note. Most manufacturers don't even recommend replacing spark plugs or spark plug wires until the vehicle reaches 100,000 miles now. That's something that used to be done much more frequently than that, but because of the materials that spark plugs and the wires are now made out of, it has become less of a need. However, it is something to pay attention to, and again, we're not just dealing with the actual replacement of the spark plugs, but the fact that we can use them as a diagnostic tool for determining other problems with the engine. In addition to that, the spark plugs, because they do thread into our combustion chamber, are an access point for other tests that we're going to be doing. For example, the compression tests that we're going to be doing in the near future. So hopefully this gave you a little bit of a background on the process of removing the spark plugs, making sure that we're keeping our spark plug wires in the correct firing order, and reinstalling and properly maintaining these components. Have a great day, everybody. Thank you for watching.